Good morning. Actually, I don't know what time it is for you. It's morning for me. Well, welcome to the presentation on slope and y-intercept. This presentation isn't going to teach you how to solve for slope and y-intercept, but hopefully it will give you a good intuition of what slope and y-intercept is. And we're going to do a little bit something a little bit different this time as opposed to what we normally do. We're not going to use the chalkboard. We're actually going to go onto the Khan Academy website and use use the graph of a line exercise to get a little bit of an intuition for what slope and y-intercept is. So when the application starts off, it starts with the equation y equals 1x plus 1. So that's the same thing as y equals x plus 1. But we see that the slope here is 1. If you looked at the introduction to graphing, I talked about that the slope is the same thing as the coefficient on the x term. And if you see here, whenever we move over by 1, we move up by 1. And I'm going to do another module on that slope is actually rise over run. So it's for every amount you rise, how much do you have to run to get that? And rise just means how much do you change in y, run means how much do you change in x. So here rise over run is just 1. And y-intercept is where you intersect the y-axis. Now, as I change the slope and the y-intercept for this graph, I think it's going to make a little bit more sense to you. Watch what happens when the slope goes from 1 to 3 halves. So 3 halves is the same thing as 1 1/2. So notice it got steeper. And if I increase the slope more, it gets steeper even more. And that's y equals 2x. If I increase it even more, 5 halves is 2 1/2. So the more I increase the slope, I think you see what's happening. This thing jumps around. I should fix that. Let me move it back. And actually, the goal is to make the line match those, go through those two blue points. That's the goal of, I guess you call it, the game. Let's see. I don't like how this thing jumps around, though. That was interesting. Let me go back there. This is, let me go back. Y equals 0x plus 1. So we could have rewritten this as just y equals 1, because 0x is the same thing as 0. Notice it's a completely flat line. No matter what x is, y is 1. And that makes sense, because this equation would just be y equals 1. Now, I've been showing you what happens to the slope. Let's see. Now, notice we have a negative slope. The slope is now downward sloping. It's downward sloping at a slope of 1/2, because let's say the rise in this situation is -1 and the run is 2. So that's why we get -1/2. And we've just been doing slope so far, and I think you get the idea that as we decrease slope, it's going to push the line further and further. It's going to slope downward even more. I hate to use a word in its own definition, but I think you see that now in the picture. Now let's put the y-intercept a little bit, and this is even more interesting. So y-intercept, oh boy, how did that happen? That was strange. Y-intercept, notice, -1x plus 2. So the slope is -1, but it intersects the y-axis at 2. Now if we increase the y-intercept by 1 more, it's just going to push this line up 1. Let's do that. See? Oh, well, this is actually increasing it by increments of 1/2. Let's do another one. I just want to see what happens on another graph, because it actually depends on the actual problem. Okay, this is interesting. Okay, this is the same thing. We start at the same point. Let's actually try to go into these two, actually figure out the equation of the line that goes through these 2 points. Well, let's see. It looks like the y-intercept's going to have to be a little bit lower. Why? I didn't know it would do that. Notice it just brings the line down as we lower the y-intercept. And let's see, I think the slope needs to be higher, because those 2 points, the line that goes through them is definitely steeper. I apologize for this thing acting up like that. That looks like about the right slope, because notice the slope is like that, and these 2 points are connected. Yeah, I think that looks like the right slope, but the y-intercept has to be lower. Let's see. Almost there, I think. There you go. So the equation of this line is 7/4 x. So 7/4, that's the same thing as like 1.75. So the slope of this line slopes faster than 1/1, and you can kind of see that. And I'll show you how to figure out all of this. I just want to give you an intuitive sense of what slope and y-intercept is. And it intersects the y-axis at -13/4. That's a little more than 3, which you can, -3, which you can see right there. Let's see if we can do another one. Let's see. And if you want, we can assign this module to you, and you can play with it just like I'm doing right here. So let's see. The line that we want to get will go something like that. So it looks like the current line slope is a little too high. So let me lower the slope a little bit. That looks about right. 7/8 x. So that means for every 8 you move to the right, you're going to move 7 up. And I'm going to draw that better in another module. This module I'm kind of doing on the fly, so I apologize. Actually, I do every module on the fly, so I guess I really should apologize. But you're not paying for this, so I shouldn't apologize. Oh, anyway, I get distracted very easily. Let's see. Let's move this line up, and you do that just by the y-intercept. You can see shifting the y-intercept up just shifts the line straight up. It doesn't change the inclination of the line. The slope changes the inclination of the line. Oh, there we go. The equation of this line is 7/8 x plus 13/4. Let's see if what I said about the slope is right. If we run 8, we should rise 7. So let's see, run 8. 1, 2, 3, 4, 5, 6, 7, 8. So that gets us right there. And then we should rise 7. 1, 2, 3, 4, 5, 6, 7. Well, that actually gets us those exact points. And we're back on the line again. I'm going to draw another thing like that for you. So if you get confused, don't lose heart. Let's do one more. Okay. Where's the other dot? I don't know. And then let me see. Well, the other dot doesn't exist. See, I got to fix all these bugs in this thing. Oh, there you go. It showed up. It showed up. Excellent. Okay, so look, we have to make the line go through these 2 points. It looks like the slope is negative, definitely. Not that negative. It's like a fractional negative slope. And it'll intercept the y-axis somewhere around here. So the y-intercept is going to be like 7 and something. 7 and change. So first of all, let's get this slope down. Oh boy, this thing's going to jump around again. Notice y equals 0, x plus 1. If we increase the slope, boy, this thing is doing also. I haven't seen this application in a while, so I must have written it when I had inferior programming skills. Let's see. Let me keep. Okay, that slope might be right. Let's bring the line up higher. No, it still seems like my slope. So the y-intercept, I'm raising the line. Oh, good. I got it exactly right. And I was right. The slope is negative because you can see it slopes downward. But it's not sloping downward that fast, and that makes sense. The slope is negative 1/3, and that makes sense because if we run 3, 1, 2, 3, we rise negative 1. We rise negative 1 right there. So that's why the slope is negative 1/3. And then the y-intercept is 22/3. Well, that's 7 and 1/3, and right there, we intersect the y-axis 1/3 of the way between 7 and 8. Well, I think that should at least give you a little bit of an intuition on what slope and y-intercept are, and I can actually you can have this module assigned for you, so you could play with it yourself. And I'm going to do some more modules where we actually calculate slope and y-intercept, and hopefully give you even further intuition on what they are. So I hope you have fun playing around with this stuff. It's actually I remember I was very excited when I first learned this stuff because it's very visual. I'll have fun.